Okay, so usually when we talk about segments at the beginning of the year, we said you could call a segment AB or BA, and it didn't matter which order you went in. Today, when we talk about partitioning, we're talking about something called a directed segment, which means you have a starting point and you have an ending point, and you have to go in a very specific direction that's given to you. So you can't go backwards. You've got to go in the direction that it gives you to you. So the first point that it gives you is always going to be your starting point, or called your initial point. Can I have somebody read the second part there where it says normally? Someone else. Someone else. Someone else. Kiki, thanks for making eye contact. Go for it.
I'm not there.
Yeah, you are. You're great. Go for it. Oh my gosh, come on. Go for it.
Normally, when looking at AB, it does not matter whether we consider point A first or point B first. But if AB is a direct segment, we would be starting point A, the initial point, and moving in the direction of point B. This direction will be used to clarify the location of the partition ratio on the segment.
Thank you. So if I give you a point, or sorry, if I give you a segment and I call it segment AB, that means you have to start at A and end at B. If I say segment BA, that means you start at B and end at A. So a direction is really important when it comes to our partitioning. Now, partitions and ratios. You can partition or break up a segment into ratios or pieces. So the ratio 2 to 3, so a ratio is one that's got the little semicolon between it. 2 to 3 indicates that the segment is divided into 5 equal pieces. So if P is the partition point, it will be located 2 of the equal sections away from A and 3 of the equal sections away from B. So if you look here at this picture, point P is partitioning or dividing the segment in a ratio of 2 to 3. So that means there are 2 pieces here and 3 pieces here. In total, how many pieces do you have? If you have 2 pieces here and 3 pieces here, how many pieces in total do you have? 5 pieces. So you can write it as a ratio 2 to 3. That means pieces to pieces. Or you can write it as a fraction and say 2 out of the whole 5. So a ratio, and you're going to write this with me, a ratio uses pieces to pieces. So it's piece to piece. So it's not the whole thing. It's saying how many parts do you have? How many other parts do you have? The fraction, a fraction says you've got a certain amount of pieces out of the whole thing or out of your total. So 2 to 3 as a ratio is the same thing as 2/5 of a fraction, which means 2 out of the whole thing. So it's pieces out of the whole. When we write our equations for partitioning, we have to use the ratio form. We cannot use the fraction form. So that's going to be something that we're going to work on practicing as we go through. Okay, so there are a couple steps that we're going to do to find the coordinates of partition points. And here are my little steps over here. We're going to follow these every time. First thing we're always going to do is we're going to draw a picture. We're always going to draw a picture. We're going to place our initial point on the left, right? So our starting point on the left and our ending point on the right. We're going to make 2 proportions or 2 fractions. We're going to cross multiply just like we did in our warm-up. And then if we're given a fraction, we're going to rewrite it as a ratio. Okay, so let's do the first one. And I think after our first one, you're going to feel a little more comfortable and more confident. I am going to say don't write too big when it comes here. Don't draw your picture too big either, because I made that mistake first period and then I ran out of space. Okay, question 1 says, find the coordinate of point P that lies along the directed line segment from A to B that partitions the segments in a ratio of 3 to 2. Okay, so which point is your starting point? A, and then which one's your ending point? B. Okay, so we're going to draw a picture. I'm going to do it out over here where I have a little bit more space. Here's A, here's B. Right, and so I'm kind of doing it like off over here so that I have enough space here and here to do my work. Okay, I'm gonna label the points. So point A is at 3, 4, so I could graph that, right? You would go over 3, up 4. And then point B is at 6, 10, go to the right 6, up 10. Okay, partition point P is on this line and it divides the segment or partitions the segment into a ratio of 3 pieces to 2 pieces. In total, how many pieces is that? 5 pieces in total. So when I go to put point P on this line, I want to show that this is worth 3 pieces, this is worth 2 pieces. So is my point P going to be closer to the A or closer to the B? Yeah, closer to the B. So I'm going to put my point P somewhere over here. It doesn't really matter where you put it. There's my point P. And I want to figure out what the coordinates of that point P are. So I'm going to put X, Y, because that's what I'm going to try to solve. Right above the picture, I'm going to label my ratio. So my ratio is 3 to 2. So this is worth 3 pieces. This is worth 2 pieces. In total, that's 5 pieces. Okay. Now we got our picture. Now we're going to make 2 proportions, and here's how we make our proportions. You're going to do your X's and your Y's individually. That means you're going to start by just looking at your X's and do the equation, then just look at your Y's and do the equation. Here is the formula that we use. We take the partition point and subtract the first point. Then we take the last point and subtract the partition point. So if you come back up to my picture, which one of these points is your first point, your initial point? A. So right underneath it, I'm going to put first. Which point is your last point? B. Obviously, that means the P is your partition point. Partition. Okay, so we're going to start just by looking at our X values, just the X values. Which one is the X value in my first coordinate? The 3 or the 4? The 3. In my partition point, obviously, it's the X. And then which one's my X coordinate in the last one? 6. Okay. So we're going to do just our X's first, and we're only going to look at my X's. And I don't know, there are some markers inside of those bins if you want to use some markers to help you out. I like to color code personally. Okay. Partition point minus the first point. So what's your partition point? X minus, what's your first point? 3. So on top of your fraction, it's X minus 3. Partition point minus the first point. The lower part of your fraction is last point minus partition point. So what minus what? 6 minus X. Good. Last minus partition. And then we set that equal to our ratio. What's your ratio? 3 over 2. Perfect. There's my equation for the X's. Now, this looks just like our warm-up problem. We're going to cross multiply now. It does not matter which one you do first. Okay. I'm going to start with, okay, remember cross multiply means you're doing it diagonally. I'm going to multiply 2 times X minus 3, and I'm going to put parentheses around it. Right, because I have to multiply 2 times that whole equation equals, I'm going to do the same thing on the right. 3 times parentheses 6 minus X. I'm leaving myself some space because I know I got to do the Y values over as well. Okay, guess what this is, friends? It's algebra! Yay! I told you guys this class was just algebra. What should I do first? Distribute. Very nice. 2 times X is what? 2X. 2 times negative 3 is what? Negative 6. Good. Now what? Distribute on the other side. What's 3 times 6? 18. What's, thank you, 3 times negative x? Negative 3x. Good. Oh, there we go. Now you just got some plain old algebra. What should I do now? Okay, so you got choices. You can literally do whatever you want here. I like to do my x's first because I'm a creature of habit. So I'm going to do my x's first. I'm going to move the 3x instead of the 2x. Why? Why is the 3x a better choice than moving the 2x? It's what? It's the smaller one. Yeah. This is a negative 3. This is a positive 2. So I'm going to add the 3x to both sides so I don't have to deal with any negative numbers. I get 5x minus 6 equals 18. Now I add the 6. I get 5x equals 24. And my last step is divide by 5. So what is that? 4.7 or 4.8? 4.8. Hooray! You got your x value, 4.8. Now am I done?
No.
Obviously not, because what do I have to do now? I gotta do the y's. Okay, so now I'm gonna highlight my y's in a different color. Y. And I'm gonna set up the equation exactly the same. I know it takes so long, but so here's what I'm gonna tell you. These types of questions, I know for a fact, are all over your cycle assessment and they're all over your final exam and your midterms. Huh? Next week.
What?
Don't worry about it, you're fine.
Bro, stop playing with this. Like, you said it's so quick too. Next week.
It's next week, don't worry about it. It's fine. I've got you. I will prepare you. You're cool. Don't worry about it. We're fine.
Is that slow stuff that we learned last time?
Then you fail it.
Does it go on a grade? Is it actually?
Just, can you all chill out, please? When we get to it, we'll worry about it.
Subject.
No, it's a chill subject. Believe me, you'll be fine. Okay? I've got you. Okay, we're doing the same thing for y's. Partition point minus the first over last minus partition. So who can set up the y values for me? Zarian, go for it. Y minus 4.
Over
10 minus
y.
y. Yep, we're only working with the y's. And what do I set that equal to? 3 over 2. Perfect. Give yourself a pat on the back. Look at that. First try. You got it. Okay, now this is exactly like our x's. Yeah, we did the exact same thing. 2 times y minus 4 equals 3 times 10 minus y. And then it's just algebra. Can I pause and let you try that one on your own?
Yes.
Yeah, I think you can distribute and try that one by yourselves. Give it a go. I believe in you. I believe in you. No, it won't be. Okay, and then put your pencil down when you're ready to check it, so I know we can go. Give you another minute. All right, ready to check? Let's check. How'd you do?
I did good.
7.6?
Yeah.
Yay! Okay, now here's the last part though. When you go, when you're finished, so you did all that work, you found your x value, you found your y value. Now, at the very end, you got to write this as coordinate, right? Because we found an x and a y coordinate. Which one comes first when you write it? The x. So your final answer is your partition point P is 4.8, comma 7.6. Okay. Questions, comments, concerns? So look, it's a lot of steps, but if you take your time, it's not hard, it's just algebra. You got a lot of algebra to do. That's all this is. No, see, math is this really fun thing where it just builds upon itself.
7.1?
6.
Oh yeah, I actually did that right, bro.
Look at you. Way to go, bro.
Oh my god, I'm sorry.
All right, let us now go to the next one, number 2. So I'll leave that up so you guys can still see it. Okay, number 2 says, find the coordinates of the point P that lies along the directed line segments from A to B and partitions the segments in the fraction 1/5. All right, let's draw the picture. Which point comes first? It would be A, and which one is your last point? It would be B. Good, so let's draw it. A, B. There's definitely more space for this one, so you can write a little.
Oh yeah, definitely. Not like the first one though.
Right, that one was rough. But so now you know how much space it's going to take.
Yes, I know how to draw it.
Okay, great. Now, I'm trying to find partition point P. It divides the segment into a fraction 1/5, which means 1 piece out of the 5 whole. Right? 1 piece out of the whole thing is 5. If I want to rewrite it as a ratio, which is piece to piece, you've used up 1 piece already. How many pieces are left? 4 pieces. Good. 1 and 4 gets me to 5. So when you go to write it as a ratio, it's 1 to 4. And that's important because the equation will not work if you use it as a fraction. The equation only works if you use it as a ratio. So it's saying from A to P is 1 piece, from P to B is 4 pieces. Where should my P be located? Closer to A or closer to B? Closer to A, because it's saying this is only worth 1 piece right here. Okay, X and Y, that's what I'm trying to figure out. And then I put my ratio right above it, 1 piece versus the 4 piece. Okay, now we're gonna set it up the exact same way we did our last problem. I'm gonna look at my X's first. I'm gonna set up my X's, look at my Y's, set up my Y's, and we'll go from there. So I will set the equations up with you. You will do the algebra on your own. Oh, maybe we should also label, this is my first point, this is my partition point, and B is my last point. That just helps with the equation. Okay. So equation is partition point minus the first over last minus partition. Who can try the X's for me? Partition point minus the first. Last minus partition. Sarah, go for it. Partition point minus the first over 7 minus X. Good. And set it equal to your ratio, which is 1 over 4. Boom. There's your X set up. I'll set up your Y's and then you're gonna do it on your own. Who can set up my Y's? Sarah, just go for it. Yeah, kill it. Y minus 1 over 3 minus y equals 1 over 4. Okay, you've got some algebra to do, babes. Give it a go. I'll give you just a couple minutes. You can work alone or work with people at your table, and give that one a go. Give it a go. And I will be right back. Decimals are okay. Do those fractions. I believe in them.
I guess the answer is
You're not here. So
party is out there upstairs. The White House building. If you want.
You have more.
No, it's been 3 days. How is that a week?
Like, we haven't seen you.
You see me.
I missed the first time.
Let me see. You know what? See the screenshot of that?
Where's that?
Oh, I'm not daddy. Not at all.
What's
Mac, are we ready? What? You didn't even start. Come on.
Let's
go.
All right, in lieu of time, let's check our work. That was weird. Okay, ready?
Yes.
Okay, final answer.
How did you, wait, hold on.
Were you doing math in the back?
I was not. I was not. Okay, how many of you at least did one of them? I got them right.
Wait, I'm not gonna look on the board. Look
X is 2.2, Y is 1.4. Notice that at the very end, I wrote it as a coordinate. Wrote it as a coordinate.
Wait, I gotta think about it right. Oh yeah? What's X?
2.2.
Oh yeah! I got one. Now let me just relax. What are you making it take?
I don't know. You guys are all telling me to go slower. I gave you guys plenty of time.
Bro, you feel like a minute in the bathroom.
Well, that was plenty of time.
The bathroom's right here. For you, not us. We have to
Well,
walk.
it seems like you were all distracted, and that seems like a you problem, not a me problem. All right, flip it over to the back. In lieu of time, I'm flipping to the back. Take a picture of it. No, it's notes. I don't give you a grade on notes because I do all the work. Why would I give you a grade for me doing all the work? No, you're just copying my work. That's two different things.
Like, you know how you give us answers like do 5 through 16 or something, we should take a picture of that and upload it, and you grade that part because you didn't help us on that.
Yeah.
That's actually true, because like you gave us multiple times.
Okay, let's move on. Number 5. Flip it to the back. Number 5. I'll put it back up at the end. You still need it. All right. On the back, number 5. Jump down to 5.
Wait.
5.
Can you freeze it first?
No.
Oh wow. Just
I
take a
got
picture.
it.
What? What do I do? I always do what?
You have to find the end.
Oh my gosh, look, it's Aaron. You already figured it out. So yes, number 5 says, given the points x and z, find the endpoint. Find the endpoint. Such that z partitions x, y in a ratio of 2 to 3. So the other problems we did, we found the partition point. This time I'm asking you to find the endpoint. Let's start by drawing a picture. What is our first point? X. What's our second point? Or last point, sorry. Whoa, careful. We don't have the partition point. What's the last point? So it says segment XY, which means you start at X, you end at Y. Bless you. Okay, point X is 3, 6. And I don't know what Y is. Y is what I'm trying to find. I don't know that endpoint. So I'm putting X, Y there. That's what I'm trying to solve for. Now, point Z is the partition point. Yes. Point Z partitions it into a ratio of 2 pieces to 3 pieces. So is it closer to the X?
Are you on number 5?
Yes.
Okay.
Is it closer to the X or am I closer to the Y? If it's 2 to 3 pieces.
If it's 50, you're closer to the X.
I'm closer to the X. Okay. So my partition point is Z.
That's funny. Thanks for the joke.
Okay, now it's time to get on task, guys. We only have a couple minutes left. We have to finish this problem.
We have 9 minutes.
I know. Okay, so this time around, I give you the first point, I give you the partition point, you have to find the end point. We're gonna still do the exact same setup. We're gonna do our X's, and then we're gonna do our Y's. So let's circle, ladies, let's circle all of our X's. Okay, now, still the same setup. Partition point minus the first over last minus partition. I'm sorry, I forgot to also put in the ratio 2 to 3. Okay, partition point minus the first over last minus partition. Who wants to go for it, Juan? Give it a try.
Will it all, what?
Shh,
How can I
ladies.
ask you a question? Will it always be
Oh, I put-
3?
Always be 3 what?
Like the ratio?
The ratio? No. I just happen to know this ratio says 2 to 3.
Oh, but it will be different though.
It could be
Like,
different.
it could be 5 and 2 or whatnot, something like
Right. Sometimes I have it like the next one is 3 to 2 over there.
that. Yeah, I was just
5 to 1. Yeah, it just depends.
Okay.
Okay. Yes.
You said first to last.
Nope. Partition point minus the first.
So wouldn't it be -1 minus 3?
-1 minus 3 over last minus partition.
X minus 1. Right.
X minus -1. Equals, what's your ratio?
What's that?
Come on, what's your ratio? 2 over 3. Okay, we're going to do the same thing we did before. Does not matter which diagonal you do first. I'm going to start here. 2 times parentheses. Now, x minus -1. What happens with minus a negative? It becomes a positive. So this becomes 2 times parentheses x plus 1 equals. Now I do the same thing over here. 3 is on the outside. Now, inside my parentheses, I could put -1 minus 3. -1 minus 3. It's -4. So now I don't have to distribute on the right. I only have to distribute on the left side, which makes my life easier.
Okay.
Right? So this one's a little nicer. 2 times x is 2x. 2 times 1 is 2. 3 times -4 is -12. Yep, and now it should look way easier. I'm going to subtract the 2 on both sides. I get 2x equals -14. And then my final step, divide by 2. X equals -7. Good. So I actually like the endpoint ones more, and so do most of my kids, because you get to kind of break it down faster and you don't have to distribute twice. All right, let's quickly do the y's. Okay, who can set up the y's? Partition point minus the first over last minus partition. I'm going to call him somebody else because you've been answering all day, Zarian. No, yeah, this is not extra. Go ahead, quickly.
So you said partition minus first?
Yep.
Okay, so 10 minus 6.
Actually, nobody's talking except for Zarian.
Y minus 6. No, minus 10.
Y minus 10 equals 2 over 3. Okay, so let's do this quickly. 2 times parentheses y minus 10 equals 3 times parentheses now. What is 10 minus 6? Is 4. So I don't have to distribute, I can just put a 4 there. And now I keep going. 2 times y is 2y. 2 times -10 is -20. I'm distributing. 3 times 4 is 12. Okay, now I want to get the y's by itself, so I add the 20 to both sides. I get 2y equals 32, and divide both sides by 2. I get y equals what? 16. Now, when you go to write the final coordinate, you do have to write your y coordinate is -7, 16. And now you're done. Okay, you're going to try 3, 4, and 6 for homework.
Oh, wow. Wait. So are we going to different points or what?
Yeah.
How?
What do you mean, how? I'm going to check them tomorrow. 3, 4, and 6.
I don't know.
Additionally, if you did not finish your Chapter 2 major grade, you also have to do that tonight as well. It closes tonight. So you might have a lot of homework tonight.
Well, how do you like, I'm like really lost.
How I grade, what do you mean?
Like a grade.
Like, I'm going to grade you for doing problems 3, 4, and 6. I'm not going to grade you for doing problems 1, 2, and 5 because I did those.
No, I was just saying, how do I know I got it, you know? How do I know?
You'll find out tomorrow. You'll find out tomorrow.
Okay.
All right, bye guys. Have a great day. Put your calculators back. I'm missing a lot of calculators.
I love how you know.
I love how I know your third period class.
I couldn't think of my third period, so I was like, girl, you have English.
Bye, guys.
I'm gonna stop the recording. Okay, bye guys. Have a great day. Stop recording.